Welcome, everyone, and thank you for attending our webinar, Graphs, the Secret to CCPA Success. My name is Marilee, and I'm part of the webinar team here at Neo4j, and I'm joined by Nav Mather, Senior Director of Global Solutions. We're super excited to have you here with us. A few housekeeping items before we get started. We invite you to submit any questions you have throughout the demo using the Questions tab located at the top of your screen. We'll answer as many questions as possible at the end of today's presentation, and if we don't get to them all, someone on the Neo4j team will reach out to you directly. With that, I'll go ahead and hand it over to Nav.
Hello, everybody. This is Nav Mathur. Thank you, Marilee, for that introduction. And I have with me today Yasser Ali, who's part of Predict Data. He's the CEO there, and he has an interesting perspective on CCPA as well. So together we will be doing this webinar, and I welcome all of you here. It's very interesting times right now, and I appreciate all of you joining in while we are worried about our families and what's going to happen. But we thought it would be prudent to go ahead with this webinar and provide information to folks who are probably stuck at home and looking for some interesting information besides the coronavirus information that everybody's digesting. So anyway, we decided to move ahead with this webinar, and I appreciate all of you joining in. So today what we're going to talk about is, what are the key highlights of the CCPA regulation, the California Consumer Privacy Act? What are the solution requirements for this? Why we think that CCPA needs a different kind of solution regarding connected data. What is a sample solution architecture look like? And then we will actually go into a couple of demos. So we will be demoing Predict Data's technology, as well as Neo4j's Privacy Shield framework, and talk about how the two come together, to solve this CCPA regulation. This is being recorded, and you will be getting all these slides in your in the mailer back to you. So no worries, no need to take screenshots and things like that. And then we will kind of end with a return on investment type of a message. How do you sell it within your organizations, and why this makes sense to do it with this graph-based approach. And then, of course, we will take some questions, time permitting. The session is going to be around 45 minutes. All right. So, Yasser, do you want to just briefly say hi?
Hi, guys. Yasser Ali. Hello from New York. Yes, pretty out of the world experience here, but customer privacy and regulations are a reality in today's world. So it's a good time to actually start thinking through some of these issues for later part of the year or planning around it.
Great. So just wanted to start out by kind of setting the context a little bit. So, we have all heard these stories, right? In the press in 2016, Yahoo was a poster child. They settled recently in 2019 for $117.5 million for the data breach. But in addition to that settlement, they got bought by Verizon, right? But that deal value got reduced by $450 million as a result of that breach. So they had to renegotiate that deal because of the breach. And so there was an immense loss in brand value, right? And that's fairly consistent with what we have seen with all of these data breaches, the loss of trust and the immeasurable hit to the brand value, right? Lots of other breaches, TJ Maxx, Marriott, Equifax, Home Depot, Sony over the years, Target in 2014, right? But also purely from a data privacy perspective, we have seen with GDPR the fines adding up in Europe. not only large companies like Facebook and Google, but also mid-sized companies have been fined. So what has happened is, especially we've been seeing all of these things happen over the last 2-3 years. But in 2014, when Alexander Kogan, now infamously, amassed over 50 million Facebook users' profile information, and then kind of sold it forward to Facebook, to Cambridge Analytica, and they used that information to basically target political ads, which was gross misuse of that information. They didn't have any permission from any of the underlying subjects or consumers to actually use that information for that purpose. So these are all the factors that made California really take the lead in promulgating CCPA. And if you look at studies out there, this, as I was mentioning, the consumer trust costs really run up in the trillions per year. So this is pretty key, and requires to be understood by corporations that are now required by law to adhere to CCPA. So with that, what is CCPA? So I'm going to just sort of highlight this from a scope, rights, penalties, and process and data perspective. So from a scope perspective, obviously anybody that has a California consumer or resident in their database needs to adhere to CCPA, no matter where the company is across the world. The business needs to have $25 million in revenue or higher, and anything that is linked directly to the consumer, any information is considered, personally identifiable, is part of CCPA. It obviously excludes public records and health information at the moment. And it does not apply to aggregated or de-identified information. From a rights perspective, right, consumers must be given access to their data. They need to know what data the organization has on them, and what it is being used for. They have the right to block the sale or transfer of this data, and they can revoke consents that they have provided previously for the use of this data. So all of this has to be seamlessly provided to consumers. And then the penalties actually can be quite stiff. On the surface, it's like $2,500 to $7,500 per violation. But that's just the fine imposed by the authorities. And per violation, it can add up, right? But the bigger piece that is being overlooked, I think, is the $100 to $750 per person per violation. So imagine if you have a million records of consumers, which is not, in this day and age, not big at all, right? Lots of companies have millions and millions of California consumers information, and so that will add up very, very quickly if you multiply that with anywhere between $100 and $750 per person per violation. And the enforcement actually starts in June, so we haven't seen anything. So people might have a false lull, or not see any penalties being awarded right now. So they might feel like nothing's happening, but actually the enforcement is only going to start in June. So there's a grace period here, and even if this gets delayed because of what we're seeing with the coronavirus and businesses not being able to function normally, that just gives us more time to actually get a solution in place. So I think this is important to understand that there is still time. And with the solution that we're talking about today, we can implement a customized solution for any organization in a 3 to 4 month period.
And one thing I'll add, Nav, since we saw this story play out about 3 years ago with GDPR. In our experience and like in the industry experience, it started off in a very slow fashion, but ratcheted up pretty fast by the EU and technology partners in general. So it ended up being that good data management practices was considered an essential item for even startups or even with organizations which have less than the given hurdles of revenues under the EU regulation. So just like history repeats itself, and the way this is going to probably play out is going to be very similar to what happened in the EU.
Great. And then finally, is the process and data. So what's the process you follow with the data you have? So first of all, you need to classify the data, right? You need to, all the data elements that are tied directly to the consumers, you need to classify them, and we'll show you that in the demo as well. But that's really one of the first steps, right? And then you need to go discover all this data, and Yasser's going to talk about that as well in his piece. Then you need to kind of see if there is duplication of the data. If Nav Mathur is in one place and Mathur Nav is another place, or it's misspelled, or all of those kind of things, right? Or there's a middle name somewhere, right? You need to deduplicate all that data. You need to merge and cleanse that data. You need to associate the data that you have, tie it back to the consents that have been provided from your marketing team, right, by these consumers. Then you need to start tracking each consumer data event. So as consumers come and interact with you, as they provide a consent, as they update their data, as they give you permission to share the data with a partner and so on, you need to start tracking all those events. You need to start tracking who in your organization has accessed this data, right? Because that might be important in the case of a data breach. So all of those events need to be tracked. And that's really where the power of connected data comes in. And then connecting all of this consumer data in the right context together, right? To understand the interconnectedness in this data, that is key to solving for CCPA. And obviously, the regulatory environment is changing, right? There are not only going to be changes within the California's, regulation going forward. More data items might get added, or the regulations changed. We have seen that to some extent at GDPR as well. But also, other states are looking into this, right? New York, Texas. Actually at least 11 different states that are actively looking into having their privacy compliance law enacted. Besides other countries, obviously Brazil already has something on the books that is going to go live very shortly. Mexico is looking into it. Canada is looking into it. India is looking into it. So this is coming from multiple different sides. The federal government is actually looking into having a federal standard as well. So this is definitely going to be changing, and you need something that can adapt to the changes.
And just to add to that, in the past few years, the regulatory environment has kind of evolved into it's the business's fault if they have not discovered the data which has been reverted back to the customer. If a customer is asking what data you have and what are you using it for, or what category of data you have on me, the onus of complying is no more. Oops, we forgot about it. But there has been quite a bit of ratcheting up in terms of if you missed out on data elements within your enterprise, it's ultimately your responsibility. And we see that a little bit in New York Shield, which is upcoming. New York privacy regulation is, as a data breach victim, you're not a victim anymore. You're actually in line for a potential fine because you did not enforce or put in place enough safeguards.
Great. Do you want to just take this slide on quickly, Yasser?
Yeah, so fairly similar blueprint of CCPA with GDPR. GDPR is a little bit more broader. It includes public bodies and nonprofits. Also, CCPA is more specifically for profit, although there's a little bit of a gray area for the nonprofit area. It is codified in law in a much more stringent manner for GDPR. However, we feel that CCPA will probably get enforced in a similar fashion as aggressively as the office of the privacy office in California and other states kind of ramp up. The violations, obviously, in GDPR are much, much higher, and they are being enforced now, which we can see in the fines for Facebook and Google, although they've not even come close to the 2% number, but they have been in hundreds and billions of dollars. The right of access, in terms of being able to provide on the website 2 methods of a customer reaching out to you to provide or request access or request for deletion, that's a moving target a little bit. Initially, it was codified in the law that there needs to be a email, for example, and a phone call to be supplied. That's kind of has probably going to get modified into maybe 1 method. So there are some of these things moving around. However, in terms of pseudonymization, anonymization of data, it's which is kind of what we'll get into a little bit later on in the conversation, is it does not apply to that. So that's a big benefit. And that's pretty much it, Nav, on this slide.
Yeah, so then going into some of the key requirements, I kind of talked about this on that first slide there, but we need to, obviously, you guys probably understand the regulation, somewhat, but why I'm showing all of these things is what is the entities behind this, right? So what are the different data elements that you have on the consumer, right? Where is this stored? Why do you have this data, right? And what are the data sources? Where did you obtain this data from? All that lineage is important, right? Because you need to be able to prove that you got this data from a legitimate source and that you had the consents to do that, right? So do you have the permission to use the data, and for what purpose, right? And also, you need to track how the data travels through your systems, because you need to go and then remove the data if the consent is revoked. So all of these things are connected together, right? Including security, right? So why is that important? Because if you look at the underlying entities behind those 9 blocks, it's these entities, right? So you have the person in blue here, and you have their data classification and the critical data elements that are part of that classification. Right here, you are also tracking the systems, applications, where this data is stored or can be accessed from, folders that have documents, PDFs, Word documents and whatnot, Excel files that have PII information. And again, Yasser is going to show you how we can discover that and bring that into Neo4j. You have on the other side of you have the consents that the person has provided, how the consents linked to the type of the consent, what is the usage of that consent. In some cases, the consent might allow sharing with a partner. So the partner entity is here, right? You are tracking each and every event. There are multiple types of events. There could be data import events, data export events happening from and to partners. You could have a data update from the person. You could have them sign up for service, so data moves from your system A to system B. So you could have a person, a user that's here in dark green or teal, whatever this color is, an employee in your organization that has access to this person's data in different systems, or not only just access, but if they have accessed that data in the last so much time, right? And obviously location of the person, location of the system, location of the data, location of where the event happened. All of these information needs to be tracked to be able to create what I call a lineage or a journey of how the customer has interacted with the organization. And that's absolutely key to trace back when a breach happened, how it happened, and also to provide that confidence to data protection authorities that you have a full lineage of the events of the journey. And so you can trace back, if there's a complaint from a customer, you can trace back to that point and say, yes, the customer did provide this consent. This is where they revoked it, or this is, and during that period of time, this is what happened. And we did, when they revoked it, we did remove all the data, and you have all the background information to prove it.
Yeah, I think the one thing I will add here, and might be somewhat controversial in some ways, is every organization has technical debt over the years. The older the organization, the more technical debt they would carry. And being able to re-engineer a full back-to-front enterprise architecture based on these privacy regulations is almost impossible in almost all the cases. And Graph Database basically provides this glue which can essentially connect these heterogeneous sources of data into a one common frame, which now we'll get into, and essentially kind of smooths out some of these friction points between your synapses of data transferring from different organizations within different teams, different organizations, different systems and databases.
Great point. So then, if you just zoom back out, what does that picture look like, right? So underlying, you have all of these systems. You have your marketing systems, you have your CRM systems, customer service, all the systems in your enterprise, right? And what we're doing is we're basically going in there to identify all the PII information, and we're bringing not the PII information specifically, but we're bringing the metadata associated with that. So what is the record identifier? And bringing those metadata back into Neo4j and connecting that together, right? So we have interconnectedness and understanding of how data in marketing is linked to the loan data, for example, or the CRM data. And when a consent is revoked, that we can tie that consent back to pieces of data in marketing and CRM together, and then remove that information, right? That's just one example, but that's the idea, is that we're not bringing all the underlying data into Neo4j, but we're just bringing the metadata so that we have an understanding of where what lives, and we can reach it. So as you saw with that connected data model, that it's really imperative to have all of these entities connected together. And this is why you need a graph, because what you saw there was a graph, right? And so it is absolutely critical that, in order to trace data through all of these enterprise systems, that you use a graph. Because if you use traditional approaches like a relational database, the queries get super complex, even with 3 or 4 table joins, and we're talking here about 10, 15. And the data model I showed you there was a simplified version. It actually has a lot more detail in the real system that we will show you here in a few minutes. And if you look at NoSQL databases, other NoSQL like Columnar or uh, you know, key value or things like that. The challenge with those is that you can get broken data paths because they're not ACID compliant for the most part. And so Neo4j, being ACID compliant and really fast at finding patterns and going through these traversals, it is the right solution for compliance regulations that require lineage. And if you have even a single broken path in your lineage, your entire lineage is basically suspect.
I think the one thing to add is for traditional relational designs specifically, and to some degree NoSQL schemas, if you know what you're looking for, setting those environments up, those schemas up is best. In disconnected systems, disconnected databases, and data stores, the main challenge is you don't know what you're getting into, what kind of where the data resides or where it might be residing 2 months from today. And being able to plan for that ends up delaying projects with requirements, ends up delaying implementation and very expensive change management. Hence, the easy, fast, and affordable, I guess, is the bottom line, which Nav is talking about.
Yeah, so let's talk about the solution architecture, right? So this is the architecture of our Privacy Shield framework. So I'll start with the bottom, right? So in the bottom, you have your system-specific adapters and connectors. So those are adapters that connect onto your underlying systems. And the purpose of that is twofold. One, to bring that metadata, as I was talking about earlier, into Neo4j, which is in the middle here, through this data integration approach, and also continuously ingest that data, right? So as the data changes, we have, you could have a Kafka queue or batch updates or whatever mechanism to bring that data back into Neo4j constantly. And then secondly, when there's a consent being exercised, or a consumer is exercising the right to not sell the data or remove their data, that needs to go back to these underlying systems, and the data there needs to be removed. So it's the back and forth that's happening there. And then we obviously have the data model here within Neo4j, and that's really the crown jewel of this solution. And then all the queries and stuff that we've written on top to then provide dashboards that we will show you in a few minutes. So we'll have a subject dashboard or a consumer dashboard that they can come in and look at their data. What data does the organization have? How are they using it? If they want to exercise their rights, they can do that. There's a management dashboard that has interesting analytics and can trace the lineage of this data. That can also be shared with a data protection authority or the data protection officer, so they can look at reports and so forth. So that's the overall architecture for the framework. Let's get into that bottom part first. So how do we do the data discovery? How do we do the data ingestion? What does that framework look like? So Yasser, over to you.
No, thank you for that. I will just go through 2 more slides before jumping into the demo, just to be able to explain our solution. Just as way of background, our team started playing with Neo4j around 2016, 2017. We were doing a GDPR implementation project at a large European bank. And what we discovered was some of the things Nav was talking about of broken data connections and the unknowns within your enterprise store. We discovered SharePoint folders. We discovered data lakes. We discovered things which were being used, and having to kind of create a brand new architecture around that was ending up being very expensive. And we were playing around with Neo4j at that time, and that's how kind of we got involved in it, and me specifically. Let me just share my screen. So basically our product is Polymer. It's Predict Data and Polymer. Sorry, it's a little confusing. But what we essentially do is in any kind of data set, we're identifying PII and encrypting it. This could be data at rest or data in motion. So imagine sending a PDF file to someone. If you push it through our process, it would automatically detect PII, encrypt those elements within your PDF document or your JSON object or your Skype chat or your Slack chat even. And on the other side, the receiver of the information would be able to unlock these pieces of information depending on permissions. So we're essentially creating these polarized views where 2 or 5 or 10 different or however many people can be looking at the same data set, but they'll see different elements of that data depending on their permissions. Just a brief process flow. Do not want to kind of bore you guys in this, but we started with the simple kind of connections with Neo4j initially to kind of do a POC back last year. And at this point, essentially, we have connected a pipeline where any kind of data source, including streaming, can be pushed through our API services. We're able to create a catalog, identify what's PII. A user can define it also, encrypt it, and then dump it into either a relational format or back to the original format. And underlying all of this has been Neo4j, and that's kind of what I'll kind of demonstrate to you in a second. So this is our, now if you can see the screen, right?
Yeah, not yet.
Okay. Oops, 1 second.
Yeah, so Yasser has basically, his demo is basically going to pull up, discover this PII information. It's going to, there we go. So Yasser, go ahead.
Yeah, so this is essentially a skin of our API services. We build these for clients also, but real magic happens behind the scenes. What you see here is essentially a knowledge map of various sources we have. I'll explain that in a second. We have a catalog summary, which essentially is traversing summations and different groupings within a knowledge graph underlying all of this information set. So we are pulling in data from structured, unstructured data, semi-structured data, and we're able to compute it back into a common data model in a graph database to be able to kind of aggregate this information using the same pane, essentially. So, and the beauty of being able to kind of putting it in this format is we can then pretty much do whatever we want to do with that data. We can kind of create all sorts of Looker reports, Tableau reports. We're able to even think about in terms of basically, dump it back into a transaction database. And what's happening is as the data is passed through, this dashboard is a combination of all the mini knowledge graphs created for your various runs, which are catalogs. And anything which is considered PII is encoded or encrypted at a node level. And hence why you see only person here and nothing else. And the idea basically is that we are controlling at a very micro level in who can see what information, and we're delinking a customer also in that fashion, where if I ever go back to it in terms of being able to start deleting, a request for deletion comes from a customer and I'm able to delete it. Some of this, there was a question by Sumit on this. Some of this data can be delinked and be stored as anonymized information just because it's in some cases, it's very hard to actually do a full delete in a database record in some cases. So let me just kind of go through one kind of quick run, which I'm going to let me just show you what data I'm actually going to be able to. I'm going to just reshare my screen here. Now, if you can see that.
Not yet.
Okay.
Now we can.
Okay, perfect. So what we have here is essentially data coming in from different sources. So this is like an S3 bucket dump of these are retirement prospects potentially. These are just prospective kind of relational database here. We have another group in terms of which is providing a subset of that customer data to target from their CRM. We have this cold call list coming in from sales from another channel. Financial prospects is another one from different channels. And then we have this like restricted accounts and being able to kind of marry those up. What we're basically going to do is essentially push it through our process and create a compute that into our knowledge map and be able to actually encrypt it or do things with it. So this can be coming in from the purposes of this call. I pushed it here, but this could be coming in from pretty much anywhere, and it could be in any kind of format, which is the beauty of this, where we can essentially do schema-less kind of dump in a staging area of a knowledge graph, and even use that as is. But you can also think about dumping these raw sources in an object store, except it's not an object store, but it's a graph database, and being able to then push it out after curating it a little bit if you need to. But schema-less by itself can work just as beautifully. And over here, we are essentially creating a key. This password will expire, but the idea here is it's going to scan through, link them up, dedupe the information, because we want to have like one view of a customer in terms of being able to see where the customer resides in different locations. This is a run which was already a run for a bunch of emails coming in, because emails is part of your enterprise kind of data set coming in from servers. So we have this knowledge map created here, but let me just open up in terms of what are the emails. And what we see here is like these related files. These are based on actual deduped information around customers, or it could be around key terms or around key values, where it's being able to create this recommendation engine out of the bat without doing any extra work for the related information sets out there. And those kind of relationships, if I explain that a little bit here, I mean, it could be as simple as like in this email, Washington Post is mentioned in two places. And for us to be able to, if we decide to, we can create this to be a common link between different kind of data sets. And frankly, it could be not just Washington Post, but you can define what that is in terms of what entity that is. So this is a run we made. I'm just a little bit over time, so I'll just try to wrap up really quickly. This is an organization which links up these different kind of data sets. We can go back to this in a much cleaner view. Sometimes knowledge maps by themselves could get fairly messy, but we like to just create specific kind of reports on top of that, just by GraphQL runs or just pure Cypher queries, for example. And essentially, what the user on the other side, once this data set is pushed out, is able to then unlock this document, or the system where they're accessing this data from is unlocked. Nav, is there anything else specifically, or I think this
is good. So basically, is Polymer then a data catalog built on top of Neo4j?
That's exactly right. So this catalog essentially is a summation of a simple queries we're running on the graph, and which can get pretty much expanded into finding common patterns or common important PII links between different data sets.
Great, great, great. So we're running short on time, so I'm just going to try to move along rather quickly. So this is kind of a marketing slide, but really kind of shows what Privacy Shield is all about. So it has role-based dashboards, tracking data movement patterns. You can kind of look at threat patterns. You can look at anomalies in your data, and that can help your business. You can do consent management, help your business again to track how well you're doing on consents in your marketing department, do what-if analysis, and so on, right? So now to get into the Privacy Shield demo, let me share my screen, and here we go. Can you guys see my screen? Yes, sir.
It's loading right now.
Okay.
Yeah.
I
While
have
we
it up.
figure it out, I can answer some of these questions. I do agree, Juan, the graph view with very large data set, we like to create filters on top of that, which are essentially groupings with a dropdown that you can create, which helps. And we're able to also dump that directly into a Snowflake or a Postgres database, some of the kind of data set to be able to visualize it through Tableau or some of the other use cases also. Proxies, Mike had a question. Proxies such as IP addresses or cookies are considered to be linkable data sets, and they are considered PII in some cases. Nav, over to you.
Great. Yeah, so what you're seeing here is essentially the front-end dashboard for an individual, for the consumer to come in, right? So it's like a self-service dashboard where they can come in and look at all the data, right? So as I was mentioning, data classification, this data, the consumer data is classified into 3 categories. There's personal data, there's classified data, and there is app data. App data is really, in this context, we've sort of mocked up a fictitious company called Netfilms, so kind of similar to Netflix, I guess. But there's data that is being generated by the company for the specific consumer. That is also under CCPA, right? So because that is directly tied to a particular consumer. So things like things that have recently watched, the history, the genres that they likes, the shares, so on and so forth. So that's, again, needs to be managed in the same way as the rest of personal data, right? So they can go and view their data, they can edit their data. By the way, the database behind this is actually very large. It has over 1 million records. If we have time, we can show you. So it has over 1 million people in there, and I think something like 50 million relationships and 15 million nodes. So it's pretty significant. And it's behaving in real time, as you can see. So here you can go and change information here and update it. So that event is then being tracked inside the database. Again, the skin is just a realization, our imagination of what this looks like. Your imagination, your company's imagination might look different, and we can totally customize that. That is why this is called a framework and not a turnkey solution. But the crown jewels, again, as I said, is the data model, the queries that we have pre-written, the reports that have been pre-written, but we can skin it any which way you like, right? You can also see who this information is shared with here, right? You can change all of that stuff. You have a summary of all the accepted consents, the activities. The consents here, you can look at the consents that have been already provided by this person, Roger. Roger can also then say, hey, it's okay for my location to be tracked, right? And you can agree to all the terms and conditions, and then now that consent is updated in the system, right? And you can see that change here right away. And now you can actually go and see in the personal data map the Rogers information as a graph, right? So here you can see all of this information. and you can see all the consents. So this is the consent, when this was consented to. You can see this is for information subscription. This is another consent. So this is the one that we just did, right? So here's the time now, today's, and then this is being used for tracking location. So you can see all the updates that have been made. The systems that that information is stored in. You can control this to the extent that you want the users to see. And this is not all the information. There's a lot of internal events that are not being shown to the user. That's only in the management view. So this is also a tabular view of this. You can look at it chronologically. So all of this is, you can also have like messages to the user and so on. We also then have the management view, which is how this information can be seen by management. You can have a lot of interesting business reports that are provided to management with using this connected data approach, right? So you have consent trends. How well is the organization doing consents? We don't have data like from 2019, so that.
And yeah, in the project we were doing for GDPR, this started off with like these kind of dashboards, but they quickly evolved into business metrics, which was the win coming up for creating these connected data sets, which was actually, it was business empowering in many ways.
Great. And so, you can then slice and dice those consents by location. You can look at, your employees and how they have access data from what location. You can have a lot of different things here. We haven't put everything here, but, you can analyze the data underlying this in many different ways and give management interesting reports to run the business, help them make decisions. This is the full data lineage. So if we go back to Roger, whose ID was 1,000, and search, and we get, now we start getting, interesting, other interesting, like internal data movement, right? Data access, who has accessed the data, right? All of this, is additional information in the management view. So this is like the complete lineage or journey for that particular consumer, right? You can also see that in as a graph, and you can start analyzing. You can then also hit this button and open up Bloom, and which is our visualization product, and explore this here. So we can look at complete lineage for this user, Salas, and see that that's going to come up in a few seconds. Again, it's going through all this underlying data, not simple, going through over 1 million users and 50 million relationships. Even in the context of this particular user, it's very significant. So as you can see, that's 111 nodes across all of those entities being brought together. You can also now start doing ad hoc exploration. So you can look at like a file, for instance, here, and look at the relationships. You can reveal the folder that it's in, like for example this folder here, and you can kind of double click that. You can trace that back to other files in that folder. Then you can trace it back to other individuals that might have files. So there's a lot of ways to explore this data in an ad hoc fashion. Sorry, I'm rushing through this. There's lots of other queries that are defined in the perspectives here. So you can define these perspectives, which are sort of natural language perspectives, and like you can look at the consents and so on, and run that here in Bloom. So this could be interesting for a business user, the DPO, the DPA, to look at this data in this way. Going back to the slides, then we are over here. So here is another query that you could have done in Bloom that looks at all systems, shared drives containing individuals' data. Again, this is the data that is brought up by Polymer into Neo4j, and now we can start exploring the data in this fashion. You can look at all the employees who have accessed the individuals' data, right? And this is really valuable information in case of a data breach.
And one thing which I'll add in this, what is actually quite the scalability factor comes in that, let's say you discover 5 attributes for a source, let's say SharePoint folder, people who have access to it, or people, what files they are in that folder, for example. But tomorrow you discover another attribute, let's say read-write permissions on the individual files, for example. And being able to bring that in a graph database, it's an easy as like a few lines of basically on the command line or just a query to be able to kind of inject that, rebuild your schema on that additional attribute. And that could just propagate throughout your graph database without impeding too much performance, which kind of makes this, the scalability factor alone, actually was why we invested in this technology and learning and building a product on it.
Right, and this is the same complete lineage that I just showed you. So just to sort of conclude from a presentation perspective, right? I think in the first slide, I talked about the trust dividend, right? And that's really kind of critical, right? So building this thing in the right way and not piecemealing it, like marketing building their own solution, security and IT building their own solution, right? And legal building their own solution to solve for GDPR does not actually solve for GDPR in the way that the regulation has been written up, right? You need to bring all of these different constituents and stakeholders together to build a single solution. And I think that graph is the right way to go because of how all of these entities need to be connected together to answer the questions, right, that are being posed by CCPA. But besides that, it's having a really beneficial impact to your brand. It's giving you competitive advantage because now you can do you can provide your business with interesting information about this data. You can do an analysis of the customer journey or the consumer's journey. You can bucket or you can categorize customers that have similar journeys together. And as new customers are coming along, you can analyze that and say, hey, which journey are they likely to take? And you can already sort of market to them appropriately, right? So all this is a lot of benefit. So you're making your spend strategic and not just trying to reduce your compliance risk, right? By spending money on compliance and making the problem sort of go away, but you're actually spending that money in a more strategic way and increasing your overall ROI and brand dividend that it's going to pay.
Yeah, and especially from an OLAP investment perspective, having a graph database, as part of that suite for any enterprise just gives developers and business much more agility and scalability to be able to view things differently and be able to kind of jigger the thing up in terms of being able to see connected information sets. Now we have a few questions here. Do you want to start?
Let's take 3 or 4 questions. I think we're really over, but let's do that.
Yeah, node level security, yes. The 4.0 version of Neo4j allows for node level security. Highly recommended to take a look at that, Joyce. In terms of JSON as an input, yes. Complex JSONs, yes, although you might need to do some work, Ahmed, in terms of being able to parse through some of the information set. We went down the path of looking at some complex JSONs and we do handle it, but occasionally there are use cases which comes in and poorly designed JSONs can be problematic. So nothing out of the box. You might need to kind of unpack it yourself a little bit. In terms of Peter asked a question, removing data using a graph database, that's gets a little bit more on the operational side. Generally, IT teams do not like, or admins, DBAs do not like outside kind of queries coming in and deleting rows out of a system. if you have to kind of design something along those lines, being able to create staging tables where your deletion queries can be stored as a line item that can be then run overnight, or then the DBA can look at it and execute those, might be a somewhat more elegant way of being able to handle it, especially in somewhat like organization with more than 20 people in it. Anything else now which kind of comes in? Polymer app is there. It's a real working app. PolymerHQ.io, would recommend you guys taking a look at the website. There's some material on some of the regulations also. How
do we get started? So I think the answer to that is, you can reach out to us, and we can engage with you in your specific situation, and we can draw up a plan of execution. We can give you a more detailed demo of this solution, and we have had customers execute this in 3 to 4 months, as I said, depending on your particular situation, and we can customize it completely for you. And with that, I think we are at an end. Murali, did you have any closing remarks?
No, thank you so much to everyone for participating. Some great questions. And again, as Nav and I said at the beginning, if we didn't get to your specific question in our Q&A session, someone from the Neo4j team will reach out directly to you and follow up with you. Everyone stay safe, and thanks again for joining us today.
Thank you, everyone.
Thank you.
Be safe.